Let me begin with a quote. I love this quote. The quote goes like this: "The science of biology has enormously expanded of late. Our realization of the nature of life, our knowledge of its processes has been changed, deepened, and intensified. A great and growing volume of fact as it goes on, growing volume of fact about life as it goes on about us and within us becomes available for practical application. But this new material is still imperfectly accessible to ordinary busy people." The quote goes on, "It's embodied in scientific publications, in a multitude of books. It's expressed in technical terms that have still to be translated into ordinary language. It's mixed up with masses of controversial matter and with unsound and pretentious publications." Finally, the quote ends, "In the care of his health and the conduct of his life, the ordinary man draws far less confidently upon the resources of biology than he might do. He is unavoidably ignorant of much that is established and reasonably suspicious of much that he hears." I think that statement describes well the situation we now face here at the beginning of the 21st century. But in fact, those words were written close to 75 years ago, in the early part of the 20th century, by the famous novelist and intellectual H.G. Wells. The quote is taken from the introduction to a remarkable book, published in 1929, that Wells wrote in collaboration with the renowned biologist Julian Huxley and his own son, G.P. Wells, a book he called The Science of Life. A decade earlier, Wells had published another monumental tome, this one titled The Outline of History, a book in which he summarized the entire history of Earth, beginning with what was known at the time about the origin of the solar system, continuing through geological history, and then through all of human history up to the Great War, World War I, which Wells saw as a culminating event in the social evolution of humankind. Now, Wells saw his project, The Science of Life, as actually being even more difficult. As with his outline of history, Wells intended The Science of Life to be read by, following his quote, "ordinary busy people, professionals, leaders in government or industry, or just curious educated people looking to better understand the nature of the living world around them and how it impacted their lives." Wells's motivation was simple. He saw that the social, economic, and political significance of biology was expanding at an astounding rate, and he felt it was imperative to educate non-specialists about fundamental issues in biology and how they impact our daily lives as consumers, as citizens, and as decision makers. At the same time, Wells saw that the rapid advance of knowledge in biology, with increasing specialization, the development of ever more obscure technical jargon, the sheer volume of material, made it increasingly difficult, if not impossible, for ordinary busy people to get some big picture overview of what the basic issues are and what's at stake with those issues. Well, it's almost 75 years later, and we find ourselves in much the same position as Wells described in 1929. Our knowledge of biology has exploded in recent years, and it continues to expand exponentially. And this knowledge plays an increasingly vital role in our everyday lives. My goal for this course is to provide you with a conceptual framework for understanding biology, much the same way that Wells attempted to provide a framework with his book, The Science of Life. As you might guess, it's Wells's book that inspires the name of this course, although, of course, we'll take a very different perspective 75 years later from what Wells did. So, where do we begin? Where do we begin to try to pull all of this together? Well, like Wells, what I want to do is to begin at the very beginning, with the origin of life. My reason for starting with the origin of life, starting the course with this, is that the question of how life arose is a useful way to begin to define what life is. And in so doing, it's also a useful way to introduce how we're going to move through this material in the course. Now, it is possible to define life by giving a list of life's characteristics. This is often done in textbooks. For example, we might include on that list that living things are characterized by a high degree of orderliness, or that living things grow, or that living things require energy for their existence. Living things move. Living things reproduce themselves. All of these are true, but this kind of list can be very misleading because each of these characteristics can be applied equally well to any number of things that we agree are not living. For example, crystals are extremely orderly. A flame requires energy for its existence. Wind moves. Oil droplets, in fact, can reproduce themselves in a sense if they grow too large and split apart. Trying to develop a list of the characteristics of living things also tends us to get bogged down in particulars, and this isn't what I want to do in this course. So instead, what I want to do is to ask more generally, what are the major issues that we need to explore in order to understand biology in its broadest terms? What are the themes around which we can organize our thinking about biology and provide a framework that will allow us to hang information together so that we can synthesize and understand it? So let's begin this lecture, begin this course not with a list of what characterizes life, but instead by asking where life came from. We'll start this story in today's lecture. We'll continue it in the next lecture. But we're going to step back at the end of this lecture and take a look on the basis of this as to how this whole course will be organized. Okay, let's begin at the beginning. Physicists tell us that the universe, as we know it, began somewhere between 10 and 20 billion years ago. Let's say about 15 billion years ago, for the sake of argument, at a moment in time they call the Big Bang. Now, our own star is comparatively young. Estimates are that it formed about 5 billion years ago, more or less, about 10 billion years after the Big Bang. Now, as our solar system was forming, cosmic dust that was left over after the formation of our sun gradually got swept up and lumped together to form planets. Planetary scientists estimate that our own planet, the Earth, reached its present size. That is, most of this material had been gathered together at about 4.6 billion years ago. And that's generally taken as the age of the planet Earth. Now, from a biologist's point of view, the early planet Earth was a really miserable place. The way that the planet was formed, with ever larger and larger chunks of material slamming into it, created an enormous amount of heat, and when the planet was first formed, it was molten. Now, my point is that we know that when the planet was first formed, it was no place where one could even conceive of life existing. But less than 1 billion years later, by, say, 3.5 billion years ago, the fossil record clearly shows that Earth was teeming with life. This life was in the form of simple cells resembling the bacteria we see around us today. This is pretty fast work, especially when you consider that it probably took about 500 million years just for the crust of the Earth to form, for the Earth to cool enough to actually have rocks and an atmosphere. In fact, some scientists now argue, again based on fossil evidence, that life might have been present on Earth even earlier, as early as 4 billion years ago. Thus, my point is that somehow life appeared on the planet almost as soon as it was possible to do so. As soon as there were rocks to record the existence of life, we find evidence that life is there. So where did these organisms come from? Where did these single-celled organisms come from? Most biologists now think that life originated on the early Earth from non-living materials, the materials that were present there at the time of its formation, and that all of the diverse forms of life we see around us today have arisen from some common, primitive, single original